Good morning. Welcome to another session of data analysis and mining. It focuses on artificial neural network with R. We start with this data frame of any size, and for example, and you want to exclude the ice row without deleting it. You want to exclude it. How you are going to do that? You are going to do this with this. When you put minus next to a number in the row section, as you can see here, it interpreted as in this way. All the columns, because this part is empty, all the for the columns, all the rows, because here it is empty, all the columns except the J1. Start with this activity. You know, for the testing phase, we do not supply the admit column. Create the testing data for the neural network. Let me explain it to you more that what is expected here. It's very easy one. Whenever we have R, everything is easy. For the training data, as you remember, we gave GPA, GRE, and rank, as well as the admits. We gave all these 4 columns of data, because when you define your neural network, E plus rank, it considers all these things. But when you want to test the data, of course you shouldn't give the answer. It's like that when you are when you take an exam, you see the answers are available with that. Okay, so what's the point of testing? So you need to remove it. But with the new versions of R, with RStudio, it automatically removes it. But still, it is good to know in the older versions how they did it. Because now your RStudio is smart enough that when you want to test it, it automatically removes the output layer. Now we are going to check it. You can check it with your R to see if it is the case. You exclude. You may ask that, Milad, is it possible that we remove a range of column? Of course it is possible. When you want to remove a range of column, okay, it is this one. And after that, you put -1 to -2, for example. The first and the second column are omitted. R is so amazing in a way that even you put this one, it still works. The same way for the other ones. Okay, my friends, now go from normalized data you have, exclude the admit column and the number column. And you can check your answer with what which you see, with what you see in front of you. Now you are ready to tell you, I can tell you another point. Have you ever asked yourself, what is the point of having this? You scroll down and up, you see different data. And I come here, for example, and I want to go for the normalized data. The normalized data. I click on that and I got this one. And you see on the left also here in the view part, you can see the table in a much better format than before. And the order and the command for that is view the data. But here I ask you to create the testing data. For creating the test, and it does Zoom show the tables and everything. The one that I'm now referring. Okay. So because I remember last session, one of the charts was not available on the Zoom, but now everything is available. Okay, so you see it is the one, but now you have the answers also with the testing data. So just remove it. Do it your way and check the way it is being done here also. Since they are very easy, just one time doing them is enough. It is very similar to WordPress in simplicity. But it is considered a programming language. I name it new testing data. So we don't confuse it with other things. And I got it here, and I got it here. And when I click it, it showed me the new one. You can see it. It's a very helpful command, since while we are dealing with big tables, many times it happens that we want to exclude a column, a row, and things like that. Okay. Now you have your testing data also available. And I told you about the reason. Compare the quality of training with the two structures of hidden layers, two structures of one hidden layer and two hidden layers. What you need to do here, my friend, here you need to do this thing. First, create the neural network with hidden layer of 5 neurons. run it, and don't need to test it because it asks you about the quality of training. It means it wants you to draw the structure and see about the error and compare them with each other, and also create the neural network with hidden layer of 3 and 4 and see the error. That's it. Go ahead. We want to see in terms of training quality, which one is better? Still, for creating the neural network, that 5 elements would be enough. And I'm running it also here. I'm gonna the structure admit, tilde, GRE, GPA, rank. And the data is the training data. We don't touch it. You see, while here we have still the number column, but it recognizes it because when it considers the data training, it gets the data according to this structure. And here, with only 5 neurons. An error function, here it is used SSE. You can use anyone, but remember, when you want to compare the performance of the structures, everything must be the same, except the structure. You cannot compare them while for one of them, you are using entropy error, and for the other one, you are using sum of a square error. It must be the same. If you are using SSE, for both of them must be SSE, and if you are using CE, for both of them must be CE. Using neural network, you need to use library. Andy, did you get the error or no? You automatically got the library. Oh, you haven't. Okay, now you have it. Have the heads up. Okay, I imported the library, and after that, we are good to and I got this structure. The structure is obvious, 3 inputs, 1 output, and 5 neurons in the hidden layer. Oh, again, you cannot see it, I guess. "28 is error." That's the things it wants you to get to. Now let's do it. And while you are doing it, and also from time to time, you can check it. or if you are checking it offline, you can stop it and do it, and after that check everything. And the structure is going to be for hidden layer C34. Because the structure now has 2 hidden layers. And there is more risk of no convergence. Let's see what will happen. Yeah, as was predicted, no convergence. We run it again. This time it's better. We plot it. It's not very critical that you think it will change many things. And also you can see the answers here, the first one, the 21. For both of them, the one with 2 hidden layers, performance is better. The one that I have put here offline and the one that I just ran. You see the error with these 2 structure is lower, the number of steps, but overall network with 2 structures with the same problem and check the quality of their training. You run both of them? Which one is better? The one with 2. Yeah. For the one with 1. Oh, really? I got the 27. 27. What about the other one? That one I got 29. Oh, but you know, it's lower. Interesting. Yeah. But you notice there. Layers are better. And then as another proof on the fact that the things are not of standard structure, because now you notice that when I ran this model, what's happening here? When I ran this model, you see here, the second one has a better performance, but Andy's model, the first one had better. That proves much better to you that there is no standard type of things that we can say if you use 2 hidden layers, they are going to be better answer. No, it is trial and error is one of the best things for neural network, especially now that, and it's a very scientific sentence that I'm telling you. You can find this sentence in many papers that they say that trial and error, just start it with some basic logical way to solve the problem and just to find the best one. But it's very important to start from a good start. Okay, now you created your neural network, you check the quality of the training. The next one, how to use a trained neural network. Exciting moment. You created the neural network and now you want to use it. You put the neural network object you created, for example, the B that I created in my system, B1. And you put the data. But what is the data that you put here? Is it the training data? Is it the testing data? It could be any of them. It could be any of them. Just you should make sure, you must make sure the data doesn't have the answers. Inputs. And I told you, for example, when you are doing it with the latest versions of R, it is smart enough to get those things. You are going to test it now. Okay, so let's go for the activity. Get the output of the neural network you built and trained last session, or only today, or even today, for the same input used to train it. So what you are going to do, you use exactly the same set of data. Now, again, use the same data, except the admit column, because it is the answer, and we don't want the neural network have the answer for that. In fact, you are testing your neural network with the same data you used to train it. The command is compute neural network data. Do it, check the result, and after that, follow me. And again, I emphasize, use the training data that you just used. For example, now in front of you, you see my system, B1, for example, B1 neural network data training hidden 3.4. Now I have my neural network and the training data is this. So I'm going to use exactly the same thing here. Even I'm not going to exclude it. Even I'm not going to exclude anything. When I put B1, R recognize that B1 is a neural network. It checks the inputs. Only the input from this training data. But before it was not like that. We needed to exclude the data from that. And today I will ask you to check it also. Okay, when it is enough, when you run it, you get the answer. We will talk about the details of these things, but today we talk on the general things. So please follow me for the general points that now I'm telling you about. This table that you see in front of you. First of all, why it starts with 3, 4, 6? What about 1 and 2? Because 1 and 2 were not part of the training data. They selected out of the sampling process that we what does dollar mean in R according to the things that we have discussed so far? It's a part of something else. Part of something else, column, part of a column. So when it puts dollar neurons, it means that it talks about some part of the neural network. And 2 here, so it says it is second hidden layer. Second hidden layer. How many neurons did we have with neural network? My structure, the second one. I want to tell you that when you get something, it doesn't mean you needed to have exactly checked the handbook. No, just go for that and speculate over the things that you see. As you notice, I asked your friend that what does dollar mean? He said part of something. Of course, part of something. And here we have 2 and here we have 4. So there is possibility that it talks about 4 neurons that are on the second. Here, you see neurons 3 and 5. So you make 100% sure that your speculation was correct. Yeah? We will talk about it. But you see, now we are in the 3. And here we have 5. But in the 4, in the second layer, we have put 4. So it needs more analysis to find the relation. But never forget that whenever you are working with some new software, some new outputs, of course, the first things that you need to go is for this. Okay, so now we are neurons 3, and it contradicts the previous things that we talked about. And I told you we are gonna cover these things in full, but now we are in the general review of the things. And also we have net dot result. Net dot result. How many things do we have here? 1. So what? How many neurons do we have at the output layer? 1. Again, go for the speculation. Again, go for the speculation, and you would say that these numbers should be the outputs of the neurons that we have. So I have already the inputs. Why? Because the inputs, you can see them here. For example, here. After that, it comes to 3 neurons. And after that, it comes to 4 neurons. So over there was 5. But now it comes to 1. Okay, so they are the outputs that I'm seeing. Of that thing. But the real output that I trained my neural network with, what was them? Let's check it. But before, let me see. My friends, I just saved the output of the neural network. I will give you time to do all the things, but just please follow me through this demo that I'm now presenting you with. And I didn't tell you so far anything about the details of the neural network. I just talked with them generally without any just speculation and things that I always encourage you to do that, because you see without any details, you can get something and you will notice that it is the output. Okay, and now I have the output. But my question from you now, the output that we get, here I show you. Here you see the output. This E minus 1, E means 10 to the power. But no need for that. Let me write it for you here. Because you will see it a lot when you are doing data analysis. See, my friends, when you see E minus 1, for example, it means 10 to the power of 9 times. So when, for example, there is 2 E minus 1, it means it is 2 times 10 to the power of minus 1, that is equal to 2. Okay, so here, now we are reviewing the first output that we have got. And we are reviewing this together. And after that, I will give you time to exercise all these things. But here, you see, it is the output of the neural network. It's a tree. In fact, the first training data set, second data set, and like that. Okay, but my question that now from you is this. If it is the output, it now tells you, I predict the output of 3 in the first data, in the first training data is, for example, 0.65. Okay, now I want you to go and check. If you are online, offline, stop it, go and check it, and return and check the answer. Go and check what was the correct answer for the first training data you gave to your neural network. Go and check it now. If you are also offline checking this thing, stop it and go and check it and then continue with that. Because we are talking about the basics of neural network and you need to have a good understanding of these things. And you notice I have no emphasis on those details of how you need to read those numbers, and I just tell you go for speculation, because since you are smart generation of technology, you can handle it. But there are something about the understanding of the neural networks that I want. First input, that is the third data in the training data, in the total data, is 0.65. What did you give it? What did you give it that now it returns to you 0.65? I'm waiting to hear your answer. Excellent. The output that you have given to your neural network are all 0 or 1. Let's check it. We have a training data. Let's get it from here. Training data. And you see, you have it. Training data, you got it. And 3, what is the output here that you gave your neural network? What's that? RE, GPA, rank are inputs. Now we are focusing on the outputs. The output now the neural network is giving us is 0.65. But what we have given it for training? 1. Okay, not bad. Now, Andy, I ask you, what is the output your neural network has given for the second? What output your neural network has given for the first one? There are differences. Go for the second one. What did you get for the second one? 0.3. The third one? And what are the real outputs here? All of them are 1, according to here. Yeah? Let me come and check with you. It's training data? Oh, your training data is different from me. That's the reason. Yeah, so, yeah. So you need to check it yourself. So you have this one. Yeah. Okay. Now check the first answer. You see? Yeah. It is 0, but it is 104. It is 1. It is this one. No? Okay. You got it? Yeah. Very good. Okay, so as you see, and we just check it together, the answers that you get are these ones, but the correct answers that you gave to your neural networks is 0 or 1. To show you in another way, we have training data and dollar. All the things that I have given to the neural network are 1, 1 or 0. But what I have got from running the neural network, it is the O. They are these numbers. None of them is 0 or 1. What does it mean? It means that we have failed in the teaching of our neural network. Let me give you another example. When we design our neural network, we put a logistic function for the last layer. We put a logistic function for the last layer. For example, we have this structure and all the things, but here, the important things for us is the last year. What was the activation function here? It was logistic function. It was 1 plus e minus x that we discussed it before. Okay, all the outputs of this, function are between 0 and 1. You cannot assign any number here to get a result that is out of this range of 0 and 1. Now, let's go with the pop activity. With Excel, try different outcomes of a logistic function for x between minus 1,000 and 1,000. Get the steps 10. Do it by Excel now. And I'm doing it to show it to you because I want to show you the reason that they are not 0 or 1 and how we can fix them. So now we have a pop-up activity. With that pop-up activity, with Excel, get the outcomes of a logistic function for x in the range of so it is the Excel, and I have minus 1,000, and the steps are 100. But you can do it on your system with 10. So first I create the range, although I can create both of them simultaneously. And I create this range. And I put it here, the function. And after that, I run the results. Okay, the first round of results that you see, I got 1, 1, and they are not also 1. They are very small numbers. 1, 1, 1, 1, 1, and here it is. You see, everything is between 1 and 0. Let's make it better. And now I'm trying to do it in a smaller range because we noticed it doesn't get any number out of this range. Let's just start with 10, minus 10. Okay, my friend. See, without any mathematical knowledge, because we can find these results from the curve, from its curve also. But I want to tell you that when you want to recognize any details about the functions that you are dealing with, you can do it in a numerical way that you can see in front of you. Now you see, when it is minus 10, it is 0.9999955. When it is minus, see the numbers, when it is minus 1, it is 0.73. And here, when it is 0, that, and when it gets numbered something like 10, it's get very close to 0. Okay. Also exercise it yourself to get this answer, to get these answers. So now you have a better understanding why all the answers that you get from your neural network are not 0 or 1, but between them, because you have given it a function that returns everything, even from minus 1 million to million to that range. And that is not a risk also to the training process. That's very promising. That gives us a huge control over the numbers that we get from our neural network that we will discuss it. But first, do it yourself to see any output with any range to logistic function. The outcomes are between 0 and 1. Did you get the point as well? neural network is doing the right thing because we have given it the activation function already. Very good. So I try my best to close this session in 2 minutes because now we are in the extra time of class, but okay, my friends. So now you get a very good understanding of the reason that all the numbers that you see in the, okay, now it is shared. Okay, now all the numbers that you see in the output layer are between 0 and 1 because you used this neural network. If the inputs that you get, now I'm referring to the chart. Now, if the inputs that you get to this part, even if they are 1 billion, the output would be something between 0 and 1 here. Next, because any number that gets into this node go through the activation function, and activation function makes it that way. You may ask, is it possible to deactivate the activation function to not getting result all in this small range? Yes, it is possible, and we will talk